Okay, so in this section, 5.2 functions, it's important that we know this definition. So function, a special relation where each element in the domain is associated to exactly one element in the range. So the domain is which one? It's the first set of numbers. And what is the range? The second. So over here in this set right here, so here I've got a bunch of points, right? Now, which numbers are part of the domain? So the 4, the 6, this 6, 8, and the 9. Those are my domains. And which ones are part of my range? So those are all the ranges. So I could just make these into little d's. So your domains are going to be your x values, and your ranges are going to be your y values, right? Now, here it says a relation that associates, we have to determine whether the relation is a function, justify your answer, identify the domain and range of each relation that is a function. Okay, so this one here, this relation associates a number with a prime factor of the number. So then some number, the number 4, and then one of its prime factors is 2. The number 6, one of its prime numbers is 2. The number 6, and then one of its prime factors is 3. The number 8, all of its prime factors are 2, so that's why it's not listed again, right? And then for 9, its prime factors are 3. Well, 3 and 3, right? But there's only actually one number. Now, 6 has 2 different prime numbers associated with it. Okay, so what do we notice about this here? So right here, 6 is the only one that has a double up, right? It's listed twice. So it's got 2 prime factors associated with it. All right, so since two ordered pairs have the same element, so the set of ordered pairs does not represent a function. So it fails the function test. This is supposed to be all right. Now we're going to look at this, what is this kind of diagram called, this one with the 2 circles and the arrows? Do you remember what it's called? An arrow diagram. So this arrow diagram, now which ones are the domain and which ones are the range? So this is the domain, and this is the range, and this is an arrow diagram, okay? Because you've got 2 ovals, you've got the first set in here, you've got arrows going to the second set, and then numbers in here. So is this a function? Yes or no? Well, let's have a look at it, okay? What we need to do is we need to check and see if any element in the first set associates with more than one element in the second set. So does any of these go to 2 of something here? January only goes to 31, okay? February only goes to 28. March only goes to 31, and April only goes to 30. So, does any of these go to 2 of these? No. Okay? So, each element from the first set only associates with one element in the second set. So there is only or exactly one arrow from each month in the first set. Okay, so there is only or exactly one arrow from each month in the first set. So the relation is a function. All right, now, what would the arrow diagram look like if it was not a function? What would be a fail? Let's say I've got this, and I've got X, Y, Z, Q, R, S, just for giggles, okay? What would the arrow diagram look like if it were to fail being a function? So if it's not a function, then I would have, let's say this goes here, and then what else would happen? Would this fail? Would this make it fail? No, that's not going to make it fail. What is going to make it fail? How can I make it fail right now? So which one? Like force it. If X went where? It went, let's say if X went to RS. So if I have 2 coming off of the domain, that would fail being a function. So this would be not a function. Okay? And let's say Z goes to R just so that R doesn't get lonely. Okay? Does that make sense? The difference, this is the difference between, so this one is a function. So you only have one coming out of each domain. And this is not a function. You have 2 arrows coming from one domain. Okay? See the difference? All right. Now in this one here, this gives you a table of values, and it shows the costs of students' bus tickets. C is for dollars, so that's the cost here, and this is the different number of tickets. So we have to see why this is why this relation is also a function. Okay. So why is this relation a function? So what can you tell me about the number in the first column? So for each number in the first column, what can you tell me? There is only one number in the second column. Right? And that would be ridiculous if it wasn't a function, right? So like one ticket could either, it's going to cost you $1.75, 2 tickets is going to be $3.50, 3 tickets is $5.25, 4 is $7, 5 tickets is $8.75. Now, if we have, like that would be unfair if it wasn't a function. So if one ticket either cost you $1.75 or $3.50, that would be ridiculous. Kind of see that? Okay, so what is the independent variable? So number of tickets is the independent variable. Independent variable is n, so that's number of tickets. And what is the dependent variable? Cost, C, cost of tickets. Because the price is going to depend on how many tickets you're buying. And then what is the domain? Number of tickets. So and I want you to list the numbers as a set as well. So it's 1, 2, 3, 4, 5, and it continues on. Close that set. And then your range is the cost. Okay, and list these numbers in the set. 1.75, 3.50, 5.25, 7.00, 8.75, and then close that set. So when it says write the domain and range, we want you to write the actual numbers that are associated with the domain and the range. Okay. And now the last question is the equation. Here's an equation. And you've seen something like this before, right? Where you have something equals a number times a letter plus another number. Okay? In relations, I think, when you did functions and relations last year in grade 9, that's when you would have seen it. Or rates of change. Do you remember doing that? Yeah? Okay. So with these kind of questions, basically you have this variable here. So n is the variable. And what it's doing is it's multiplying with this coefficient, with the 25. So it's 25 times n and then plus 1,000. That's the equation that represents the cost, C in dollars, for a feast following an Arctic sports competition where n is the number of people attending. So describe the function and write the function in function notation. So to write something in function notation, we just change it slightly, the kind of the first part. So we're going to change this part only to write it in function notation. So here it's the cost of the feast is a function of the number of people attending. And then in function notation, instead of writing C, I'm going to write C of n. Now, this does not mean multiply when it's in function notation. It means that C is a function of n. So n is the variable that's listed on the other side of the equal sign. So that's the only difference here. It's this part means C of n. That's what this means here. Okay? That's how we read it. So then here I say determine the value of C of 100. So when you have a bracket here, that means you're going to substitute 100 for n in the equation. So C of 100 is going to be 25 times 100 plus 1,000. So then I just use order of operations and I complete this. 2,500 plus 1,000. So then my final answer here is going to be 3,500. Whoa, that's an extra zero. $3,500. Okay. So what does this number represent? Well, here, I'll write my sentence here. This means when the number of people attending is 100, the cost will be, what's the cost going to be? 3,500, yeah. 3,500. Okay. And now in part C, I want to think about what the question's asking before I actually do it. So I'm going to write down the original equation. So this is the equation in function notation. Okay. And then it's saying determine n when C of n is equal to $5,000. So what do I have to figure out in my question? How many people are attending? How many people are attending if what? If the feast costs $5,000. All right, so how do we set this up? Well, where do I put this 5,000? Where does this number go? So it says it's equal to Cn right here, right? So that's what Cn is over here in the equation. So where should I put the 5,000? What's my new equation going to look like? Okay, so C of n, this is a notation. This does not mean C times n. This means that the cost of this means the equation. Like, it's like the y equals equation. It's exactly the same as that, okay? So keep this all together when you're replacing this 5,000. That goes in right here. So it's going to be 5,000. So instead of C sub n, we have 5,000. And then we have our equation. So this replaces this. So we've got 5,000 equals 25n plus 1,000. And then what we're doing is we're going to solve this equation for, what do we do here? Solve for n. So we need to isolate n. So what are the steps to isolating n at this point? So subtract by 1,000. So you're going to have 5,000 minus 1,000 equals 25n. And then that's going to be 4,000 equals 25n. Divide both sides by 25, and then this becomes n, and n equals what? 160. So we have n equals 160. So what does that mean now? Yeah, so when the cost is $5,000, that means that 160 people attended the feast. Okay? All right, and your homework is right here. Okay?